In Module 2, you will learn about the formation of planets from dust in a solar nebula. And then we'll get into the internal differentiation of planets into a central core, mantle, and outer crust. You may have heard that we are all made of stardust, and this is absolutely true. The atoms that make up you and the matter all around you were formed in the heart of a star. So around 4.5 billion years ago, a supernova explosion of a massive star formed a giant cloud of very hot gas called a nebula. According to the nebular hypothesis, the solar nebula condensed into a spinning disk called a protoplanetary disk. And at the center of the protoplanetary disk was our young sun. As the protoplanetary disk cooled slowly over time, droplets of solid materials began to form. These solid materials would eventually grow into the planets we know today. So we know a lot about the earliest materials and processes going on in the protoplanetary disk by studying meteorites. Meteorites are very special objects that originate from outer space. They include the oldest materials in our solar system. So how do planets grow? Planets are thought to form out of particles of dust that collide and stick together to form larger and larger and larger bodies. And so the growth of small bodies relies on random turbulent motions in the gas to cause those collisions. But as the planetesimals start to grow, or as these larger bodies begin to grow, they start to attract other bodies by gravity, and then they turn into what are known as planetesimals. Planetesimals, once they grow, and they turn into protoplanets once they're 100 kilometers to 1,000 kilometers across. Planetesimals and protoplanets grow by impacting other bodies, and this is a process known as accretion. Okay? These impacts can be very, very powerful depending on the mass and makeup of the impactor. Basically, the bigger the impactor, the more powerful the impact. Planetary accretion by impact added mass to the planetesimals, but also contributed a great deal of energy to these planets. And this energy is necessary to melt the planetesimal, which leads to planetary differentiation. So recall that planetary differentiation is this separation into different layers within a planet, so a core, mantle, and crust. This energy for this very important process also came from radioactive decay of short-lived isotopes, which were much more abundant in the earliest stages of the solar system. Also, as these planetesimals grew, the pressures within them began to increase, and that also contributed to melting. Planetary differentiation, again, is a separating out of different constituents, and these constituents have very different physical and chemical properties where the body develops into compositionally distinct layers. For planets, we're most interested in the separation between iron, metal, and stone. And this separation between iron, metal, and stone is really well represented in palisite meteorites, which are stony iron meteorites. And these guys are thought to originate from the core mantle boundary of differentiated asteroids. Iron, metal, and stone have very different densities, and it is this contrast in density that causes the layering in bodies. So in this module, you'll learn about the role that this physical property has on the internal layering of planets, as well as in lava lamps. So basically what happens in lava lamps is that the wax heats up and it expands. And so the density lowers and it becomes more buoyant and starts to rise upward. Okay? As it reaches the top of the lava lamp, it starts to cool, and the wax will start to contract, and that increases the density, and it will sink. Okay? And this is an important analogy for thinking about many different processes within the Earth and other planets. Also, in exercise 2, we will do some calculations of density of different materials and make inferences about the structure of planets. In the very last section of this module, you will learn about the giant impact hypothesis for the origin of the Earth's moon. The giant impact hypothesis posits that The moon formed about 4.45 billion years ago when a Mars-sized protoplanet called Theia made a direct impact into proto-Earth. And so there you have it. Planets are built from stellar explosions and giant impacts. Get out the popcorn.